Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of solving scale problems. This is 7.5C Readiness Practice, the advanced version. If you are interested in exploring the 7.5C Readiness Practice for the intermediate or proficient versions, or the Readiness Practice resource aligned with any other standard, you can find those by using the link in the video description. All right, so we have a rectangular swimming pool. Let's draw a rectangular swimming pool here, and it's 15 by 9 centimeters long, at least the blueprint is. All right, so this is my swimming pool, put SP right there, and my length is going to be 15 centimeters, and my width is going to be 9 centimeters. Now, the scale is 1 centimeter equals 2 meters. So 1 centimeter equals 2 meters. First, we need to figure out what is the actual dimensions, length and width of the swimming pool in meters. Well, it seems pretty straightforward here because look, each centimeter is equal to 2 meters. So I'm just going to take each of these centimeters and just multiply it by 2. What I'm going to get is 18 meters. And then I'm going to get 30 meters. So that's my length and width. So let's put that up here. My length is going to be 30 meters. And my width is going to be 18 meters. And we can circle those. Now, we also have a rectangular rec room that is similar. So that's going to be important. So it's similar to the swimming pool. All right, so let's draw another rectangle. And this one is going to have an actual length of 20 meters. So my other actual length is 30 meters, which means it's going to be a little bit smaller, the rec room. So I'm going to try to make it similar and a little bit smaller. It's going to have to be close enough. All right, so this is my rec room. And my length is 20 meters. Question is, what is the width in meters? Well, they're similar, so we can set up a proportion or we can find the scale factor. Okay, either one works. Let's start with the proportion. So what I'm going to do is I'm going to say length over width, length over width. This is going to be my swimming pool. This is going to be my rec room. So this is 30 over 18, and this is going to be 20 over what I'm looking for. So we can cross multiply. We can say 30x equals 20 times 18. And so 20 times 18 is going to be 360. So if I divide both sides by 30, that's what I'm going to get. I'm going to get 360 over 30. That's like 36 over 3 if you drop out the zeros. So that's going to be 12. All right, so I can write this as 12 meters. Now, another thing I could have done is I could have figured out what the scale factor is, right? And so my scale factor, right, is getting smaller. And you can take a look at what we know. We know it's 20 over 30 in regards to length over length. That's 2/3. So I could have taken 2/3 of 18. Also would have got me 12. So that works as well. So either way, the width is 12 meters, the actual width of the rec room. Now we need to put that back into the same blueprint and figure out how many centimeters that is. Okay, so let's use the same scale. 1 centimeter equals 2 meters. So I'm going to take my 12 meters, divide that by 2, right? 12 divided by 2, and that's going to give me 6, so 6 centimeters. So a 6 centimeter width is going to equal 12 meters in real life. So that's a lot of scales, and that's a lot of back and forth, but those are our answers. Next, we have a rectangular garden, and it's represented on a scale drawing. Let's draw another rectangle here and say this is going to be 3 by 2. And so let's see if I can get one that looks kind of similar. All right, so we'll say this is going to be 3 inches. It's going to be my length, my width, 2 inches. Okay, so the scale here is going to be 1 inch equals 4 feet. And we're going to be covering this with a grass sod that costs $2.50 per square foot. This is dealing with area. So what is the actual area of the garden in square feet? Well, first let's change these inches into feet. Okay, I'm going to multiply each of these by 4. What I'm going to get is I'm going to get 12 feet. I'm going to get 8 feet. So the actual area is going to be 8 times 12. So that's going to equal 96 square feet. So let's put that right here. 8 times 12 is 96 square feet. That's one of our answers. Now, how much will it cost? Well, remember, it's $2.50 per square foot. So now I've got to take my 96 and multiply that by 250. I'm just going to drop that 0, make it 2.5. And so that's going to be 30, 45, 48. That's going to be 12, 18, that's 19. That's a 0, that's a 14, 24. Now, we've got one digit behind the decimal, so I need one digit behind the decimal. So it's going to cost $240 to completely cover that. So 240, circle that. Now, a second similar garden is constructed with side lengths as long as twice as long as the original garden. So what would be the cost to cover it with sod? Well, you would think if you just double the side lengths, you double the cost, but that's actually not how it works because we're dealing with area on that one. So let me draw a larger rectangle and show you what I'm talking about. All right, so I'm going to try to make a rectangle that is twice as large here. Now, I'm not going to deal with the scale drawing. I'm just going to deal with the actual length. So this is 12 feet, but I'm going to multiply that by 2. I'm doubling that. So it's 24 feet long. This is 8 feet, but I'm going to double that because it says the side lengths are doubled. So it's really 16 feet long. So what's my area? Well, let's figure out what my area is. My area is going to be 24 times 16, and that's going to be 24, 12, 144. Then I've got 24 right there. So I've got 384 square feet. Now here's the interesting thing. When you're dealing with area and you are doubling each side length, look what happened to my square feet. My square feet went from 96 to 384. That's not doubling. If you double the length and double the width, what you actually do is, let's take a look at this right here. 96 times what gets me to 384? Well, if you were to divide 384 by 96, you know what you'd figure out? It's by 4. When you double the length and double the width, the area is actually quadrupled because it's not just times 2, it's 2 times 2 because you double the length and double the width. If you just double the length, you would make the area would be twice as big. If you just double the width, it would be twice as big. But if you double length and width, it's 2 times 2, that's 4. So I could do this. Since my area is 4 times as large, I can take my 384 and multiply that by 2.5, the 250 each, or let's just take a shortcut. Let's just take our actual cost. What is our cost for a 96 square feet? 240. And I know that my area is 4 times as large. The price is the same, so I'm just going to multiply that by 4. It's going to get you the same thing. So that's $960. So let's put that right there, $960 to quadruple that. We also could have gotten that if we took our 384 and multiplied that by the actual unit cost of 2.5. You're also going to get $960. Either one of those work. All right, so now let's take a look at our last problem, number 3. We have an isosceles trapezoid. It's similar to the isosceles trapezoid. That word isosceles is going to be helpful because what that means is that the two slanted sides are equal. Now, they're rotated in slightly different ways, and so let's color code this, right? So this big base here goes with this big base here. This shorter base goes with this shorter base. If you can imagine that it just rotates, right? Counterclockwise 90 degrees. And that means that this slanted side is going to go with, I'm looking for GH with this slanted side. So we're missing that one right there. So we can find the scale factor. We can set up a proportion, right? Let's set up a proportion. Let's say I've got my 12 centimeters. I'm going to do my greens over my reds, or my greens next to my reds. So 12 to 9, right? So that's the bigger trapezoid to the smaller trapezoid. So then I need my bigger trapezoid, 5 cm, to my missing side length. Now, I could have done my purples, and I would have gotten the same thing. So I could have done 4 cm to 3 cm equals 5 cm over x cm. Let's see, just to verify that you've got options. So this is going to end up being 12x equals 45. This is going to end up being 4x equals 15. Doesn't look the same. Well, let's divide. All right, let's divide both sides by 12. Let's divide both sides by 4. And so 45 divided by 12. Let's do that one first. That's going to be 3, not quite 4. That's 36. So that's 9. 9 is going to give me decimal 7, 84. And 60 is going to be 5. So 3.75. If these proportions truly are the same, then I'm going to get 3.75 when I divide 4 into 15. 4 into 15, it's going to be 3 times. It's 12. And we see what's happening here. That's going to be 30. 7 times, 28. 2. 20 goes in 5 times. So either way you look at it, either proportion works. The length of side GH, let's put this right here, 3.75 centimeters, and then let's circle that. Let's do that with a, there we go, let's circle that. All right. If you are interested in exploring the 7.5C readiness practice for the intermediate or proficient versions, or the readiness practice resource along with any other standard, you can find those by using the link in the video description.